What's up guys, Sam here and welcome back to Samcraft. In today's video, I want to bring you along as I evaluate my filament storage solutions and talk about humidity. Humidity is a big factor when dealing with 3D printing, so I want to talk about what systems I have in place. I want to test them to see if they are effective or not, and also share with you guys a story about a disaster I had in this workshop. So I brought you guys over to this area of the shop to show you the water jet because that was the source of the disaster. Apparently I have a couple of faulty parts in the machine that have been sent for replacements from the company, but it caused the hoses inside the machine to disconnect. Unfortunately, two things happened. One, I forgot to shut off my water supply to the machine, which they tell you to do when you're not using it. And two, it happened when I wasn't in my shop. So I want to roll a little bit of footage here of the rude awakening I received literally on a Monday. What a great way to start the day. But it was finding that my floors in the shop had been freshly washed. Pretty terrible, right? Yeah, that made for a rough start of my work week. So over the course of, well, it's a week ago today, I have been running fans in here non-stop. I've had my air conditioning units on dehumidifier modes. I've had the windows open as much as possible and really been working to dry everything out. However, I needed to do something supplemental. I needed to help this along because my humidity levels were still high and I started to notice quality issues on my 3D prints. So let's go to the 3D print corner of the shop and I'll show you guys what I've put into place as of this morning. So over here in the corner there is the new addition to the Samcraft shop called Mr. Dehumidifier. This guy is set to pull the humidity down to about 30%. It's adjustable with this model and I'm going to try and pull the shop's humidity down. As you can tell, right now we're sitting at 55% humidity, which is high for homes, but it's extremely high for my shop considering I have had my mini splits running on dehumidification mode for a week solid. I've also been running fans. It has been drier outside, so we have not had rain for a long time, and it just shows how honestly wet this workshop still is. Changing over to my little magnetic thermometer hydrometer, is that hydrometer? Moisture level detector. You can see down there at the bottom the maximum humidity it recorded, and yikes, stripes, fruit stripe gum, that was insanely high. And so as you can tell, my workshop is a little bit moist, which is not good at all for these guys. Doing a little googly foogly kung fu, searching what the recommended humidity level for PLA filament storage and use is, they want it below 45%. So obviously, I'm beyond the red zone. I'm in no man's land. I'm halfway to the moon on the humidity level, and I really need to get this under control. Now, thankfully, this is not going to affect my new filament storage because they stay in the boxes. They are in their plastic wrap with their individual desiccant pouches, and I feel like those are okay, which is very good because this is a big investment as far as filament. My main concern, however, is with all of these bad boys. All 24 of my A1 printers have at least 3 or 4 rolls of filament on each individual printer. That's a lot of filament out in the open that honestly has been acting like sponges this whole past week as I've been working to dry out my shop. So that's not good. This probably leads to the question, alright, are there solutions you can put in place? Hey Sam, we've seen some other people print enclosures for those spools and keep it drier. That is an option, definitely it is an option, but I feel like that would quickly become a logistical nightmare as I try and manage all of these printers as far as unloading and loading filament within their enclosures, and then would it even fit? I have got this whole shelf system Campbell soup condensed as tight as possible to where I can fit 8 printers on a single shelf. I don't want to give up any leeway on that. I want to stay a stickler Sam over storage space. So I don't know that that is a solution that's going to work well for me. Which brings us back to the corner over here with the dehumidifier. I'm going to consider this little white box of magic the newest addition to my shop, and honestly 3D print operator numero uno, being the #1 thing that needs to run all the time in my shop, or at least be set to where it turns on and off exactly where it needs to on humidity levels. Okay, so I brought these boxes up off my shelf so that it's easier for me to talk to you guys, but you still see the stuff that we're talking about. This is my current used or opened filament storage solution for the specialty colors, right? So the majority of my colors I have default on green, a new product line coming out with default of blue, and so those are going to stay on the machines all the time. These, however, are the opened colors for the custom color orders that I also give my customers the option to buy. That was kind of difficult to say. So my thought process with this was get a clear tote that I could fit as many filaments in as possible, something with a nice lid, and throw my desiccant packs every time I open a new spool into each one of these boxes and kind of sprinkle around like little sprinkles of desiccant land. I think it's been working good, but to be honest, I've never tested it. So, using my same little thermometer hydrometer, I'm going to test it out. So this guy right now is saying inside room humidity is 53%. It's going to go up by me holding it because I guess I'm a humid creature, but I want to check and see really quickly if I open this lid, throw this guy in, what level does it equilibrate at? Because I feel like that will tell me what this inside enclosure humidity level is at. Hopefully it's very low, right? Because I'm operating under the assumption it would be very low. Let's find out. So let's go ahead and plop in that guy. Oh, that's nice, nice and crooked. Shake and bake down. Ah, that's even better. Oh well, let's hang on. Okay, I have finagled that guy around. It's now here in the bottom corner. Let me zoom in and let you guys watch that. Let's see how long it takes to equilibrate and what level we get to. Well, Houston, we got a problem because that guy has bottomed out at 50%. That's not good. That's not good at all. While I was waiting on this guy to get, I don't know, settled. We're going to say settled or equilibrated. We were really good. While I was waiting on this one to adjust, I did a little more Google research, and instead of taking the AI generated result, really scrolled through some other websites, and honestly, my PLA filament should not be any more than 40% humidity. Yikes. That's terrible. Because they're honestly probably sitting at close to 60% right now on the machines, and apparently 50% in my boxes. Let me check the others real quick in case me fumbling around with this one messed it up, or in case maybe the desiccant's old. Let's just check it real quick. Alright, this box has not been opened in a long while, so if I can move this sensor fast enough, we should be able to get an accurate reading. Alright, it's reading 50% still, but let's go ahead and throw it in here really quick and see what we get. That's about as fast as we can go. Alright, that guy's been in that box for about 15 minutes and it has settled down to 47%. That's not good. Not good at all. So, what do I know? Alright, so we've got a bunch of measurements. My current solution is not working. My shop issues I have with the water is in and of itself a thing. Hopefully not one that ever repeats itself, but that is absolutely affecting the humidity in the shop. So solution step number one, get the humidity out of the shop. Run that dehumidifier, keep my mini splits on dehumidification or dry mode, and just keep hammering it. As we can tell from the meter, the maximum humidity that the shop was at one point was 69%. So that's pretty terrible. It tells you that at one point, 69% of my air was moisture. Okay, at least I think that's how it reads. I'm not sure, I'm not a weather guy. But 69% humidity in a shop, especially a 3D print shop, nightmares. Pretty much nightmares. So yes, step one, run the dehumidifier nonstop, pull down the ambient or relative humidity in the air. Step number two, apparently I need to improve my open filament storage solutions. Now these boxes don't have any kind of gaskets on the lid. I deliberately did that because the ones with gaskets on them were much more expensive. These were more affordable, these were a proper size, and the others were not. So that is on me. I could probably run down the rabbit hole of just throw money at the problem and get some gasket tubs and really do that a lot more. But what I want to try first is testing out the desiccant packs that come with the filament straight from the manufacturer. Maybe I'm already working with and hindered or not as good of a solution system right out of the gate. So to test whether or not filament arriving to my shop is dry or is that desiccant pack spent up, the best idea I've got in mind is to get a gallon-sized plastic Ziploc container bag, open up a brand new roll of filament, and quickly throw it in that bag, zip it shut with the meter inside. I will then wait to see what it levels out at, and that will tell us, as close as possible, what kind of humidity levels I'm working with from the factory. Alright guys, I got the moisture meter out. I have a gallon bag, and I've got an unopened, very new to the shop, so this was delivered maybe like 4 days ago, refill of Bambu PLA Basic Filament. So from the factory, these rolls come, I guess, you know, say shrink wrapped or vacuum packed. They have a desiccant pouch inside and they're sealed up. Of the hundreds of filaments I've purchased from Bambu, I've never had one arrive not in this shape. So no package has ever been broken or damaged in shipping, which is good. Let her rip, Tater Chip. And why not? We'll throw the desiccant pouch in there too. Now I'm going to push out all the air, zip it up. Nice, that actually went very nice. Okay, so we are in the Ziploc bag with the desiccant pouch, the original filament from Bambu, and our moisture meter. Let's see where it's at now. While that meter is sitting in that brand new roll of filament, I've already thought ahead to something I should do that I really should have done from day one, and that is print some little containers for me to fill in my own desiccant that I buy and put inside my clear totes. So let's go ahead and launch Bambu Studio. Let's get on their MakerWorld site and see if we can find a cool print file that we can download and print to put our desiccant in for the clear totes. Now what we're going to initially see is probably a lot of stuff that is designed to go inside of the AMS for the P1P, P1S, X1 Carbon series. I've printed those for mine, they work good, but I'm looking for something that is external. Option number 2 here on the results looks pretty good, desiccant box. So let's take a look at this one better. It's got a nice size, I like that it's large, I like that it will hold a lot of desiccant, that's going to be very helpful. It looks pretty good, straight and basic. They got a print profile for the A1. I'll probably do that one, but let's go see if there's anything else while we're here. Yeah, see this guy right here? This is what I was talking about, how you can print a little pouch to put desiccants in your AMSs for the P1 and X1 series. We don't have that luxury with the A1 since our AMS light is open to the air. Well, while I'm here, let me go ahead and show you. So here are some examples of the enclosure that you can print and use for the AMS light. So this is probably an idea that a lot of people, if they are familiar with this, will say, hey, just print your enclosure. My problem is more logistical. So if I have this apparatus on all 20 something of my printers, it's going to be really hard to be able to unload or load filament. Not to mention this is designed for the AMS with stand, and all of my printers have the AMS top mount system. So that's not going to work for me. Alright, I'm just going to pick this guy right here. He's got, looks like 746 downloads, 78 likes, 40 boosts. Looks pretty good, and honestly it's perfectly fine for what I need. So let's go ahead and download and open. I'm going to change my printer to the A1 with the 0.4mm nozzle. I'm going to use his modified settings. And PLA Basic, good. Let's slice this guy up, see how long it's going to take for 2.5 hours, not too bad. Let's go ahead and Control A to select all of them, copy and paste. Let's see if I can fit 4 on here. I don't know if I can. Yeah, the auto arrange is not going to let me do 4, so how about there we go. I can fit 3 on a build plate. That's not bad. I have 5 totes total, so yeah, no big deal. Alright, slice this one up. Okay, This is now going to take 7.5 hours, but we need it, so let's do it. Alright, so while that is going and cooking and booking, let's go ahead and check back in with our brand new roll of filament, and let's see what the humidity level is from the factory. Alright, new filament is only reading 41%. I mean, I guess it's good, right? Google told us no more than 40% relative humidity. I would have hoped it would have been a lot lower, but it is what it is, right? So this tells me my filament is borderline straight out of the box. Okay, at least this one particular one. Maybe this is an anomaly, but it's what I'm rolling with. And that I really don't want it to add any more humidity to this roll of filament before I use it up. Now, it's worth mentioning, prior to the washing of the shop floor, I haven't had any issues at all with my print jobs, and I've been using them like they are. I didn't have the humidity level out here, the meter, so I don't know what I was running at before, and so unfortunately I can't tell you what that is. I feel like probably my shop was really hovering around the 45 to 50% relative humidity level, and I didn't have any problems with print jobs at that point. So if I can get to that point, I'll be happy. I consider this filament being 41% relative humidity out of the spool and, you know, transferred to the bag, good enough for my uses, right? This is just regular PLA. It's nothing fancy that needs to be dried before use like other advanced filaments, and I think it's probably the best I'm going to get. Alright, so at this point I was thinking that I was going to stop the video and give myself several days to get the humidity level of the shop down, let the desiccant boxes finish, and then come back to you guys. But I realized that I actually have a solution that's going to tell me if my print issue is humidity related or not. So first, let me show you a jig that printed out the other night and show you the poor quality of it, specifically with the top final layer. As you look at it here, hopefully it will show through on camera, but it has a very rough texture, which with PLA basic filament is usually very smooth and shiny. This texture is more like sandpaper, or it's got little crumbs in it, or something different. Also, around places where the hot end would jump and kind of go to a different point, maybe it's not really bridging, but just travel moves, there is more spaghetti, more strings, more fuzzy hair looking type stuff, and it's really just not a clean print. The thing I've come up with that I can test this out real time to allow this content just to get to you guys faster is to use that brand new roll of filament we just opened. It's sitting at 40 to 41% humidity. Let's go ahead and load that on a spool, throw it onto a printer, and print that jig file right now. Hopefully by the time the jig file gets printed, it will not have absorbed so much moisture to cause problems, and it will tell us yes or no. Are we chasing a humidity issue appropriately, or am I off on some random tangent that's not going to improve my issues? Let's find out. Alright guys, 2.5 to 3 hours later, and that print job is finally done, and as you can see here, it looks much better. Much better. This is back to more what is normal for results. So what does that tell me? It tells me I have a bunch of wet filament. What can I do about it? Well, as this print job was running, I did some Google research, started reading into more forums, community posts, and stuff like that on how to dry filament, and if filament is exposed to a moist environment, how to then dry it. So there's steps to dry it from the beginning, and there's also steps people talked about from drying it in my case. The initial thought would be, okay, if it soaked up moisture over a week, just let the dehumidifier run and keep it dry for a week and you should be good. However, a lot of the reading that I was reading tells me that the plastic does not release moisture as easily as it will absorb it, and that what you need to do to properly dry your filament is to not only dehumidify it, put it in an area with low relative humidity, but you also need to apply heat. Some printers, such as the Bambu P1S and X1 Carbon, can become filament dryers in and of themselves. They're enclosed, they have a heated bed, and they have a dry filament option. These A1s don't. The other thing I had to look at is that, alright, I don't just have one printer. I have 24 printers, and each printer has anywhere from 3 to 4 rolls of filament on it. Round up or down for Math Town, and that gives me 75 rolls that I need to dry. Yikes. There are commercial options out there for filament dry boxes, but none of those seem to be applicable to my unique case, except for one idea. This one I think came from Reddit, I think, but I was reading all over the place. And this idea is actually what I just purchased, and that is a commercial food dehydrator. That's going to allow me to dehydrate and add heat to the enclosed cabinet and also put as much filament in there as possible. The one that I ordered has pretty good reviews. It is larger at around 23 cubic feet of internal dry space, which should allow me to stack the filament rolls in there and get as much done as possible. However, that's not going to be in this video because Amazon says it's not going to show up for a week. And I would rather get this content out to you all sooner than later, and then also do a separate video about drying filament with a food dehydrator, as interesting as that's going to be. But we did find out a lot of good stuff today, right? We determined that yes, my issue was related to wet filament. We also found out how dry or wet filament was straight out of the box from a supplier, so it was not too dry. And we also found out that my current way of storing open filament in my plastic boxes reusing desiccant packets is a bad idea. My desiccant pouch holder boxes that we showed earlier, they're still printing. So they're going to replace the pouch method that I've been doing, and I'm going to be using true desiccant in there and doing a better job. That I will give you guys a follow-up on my next video, which is going to be about the food dehydrator and filament fun. So look for that one there. If you're here from the future, look down below. There's a playlist to all of my 3D print related videos, and you will see it there as well. In the meantime, hopefully this video was informative, maybe educational, maybe you learned some stuff along with me as I was learning stuff. Maybe you already knew this. There's a whole slew of people out there, so that's totally possible. For me, I'm just bringing you guys along as I continue to progress through my 3D print business and learn stuff, share, tell, and we just have fun together hanging out in the shop. If you got any questions or comments, leave them for me down below. Otherwise, take care. I'll see you guys next time in the workshop.